carrier frequency, right? Okay. The bandpass filter will not be, I guess, will be the filter will be introduced in another module, HF technique, right? Have you taken HF technique? Not yet, right? Okay. Here, this gain is amplified. Okay, will be explained in this module. Okay, so the amplifier here. Notice there are a number of filters. This BPS is a bandpass filter. Actually, suppress the maybe interference, right? Okay. This one is mixer. Is a mixer. Okay. This is a local oscillator. Also, mixer. This oscillator is used to generate the carrier frequency. Okay. Generate the carrier frequency. For instance, 2.4 gigahertz. Those information kilohertz. Okay. This information signal is low frequency. This is a very high frequency. Okay, very high frequency is gigahertz. This is kilohertz. Okay, kilohertz is 10 to 3. This gigahertz is 10 to 9. Okay, right? Then I will explain this. So this component we expand. Okay. First, we will introduce in this module the specifications. Nowadays, although later I will explain how to design this, but typically for those very common frequency band, typically just purchase the commercial available. So most of the time, maybe you need to understand the specifications, then interact with the system engineer, right? Okay, provide, then purchase those commercial available. Okay, then build the PCB board. Okay, so this also we will explain how to design this. Signal generator or source oscillator. Okay. This also amplifier. This is amplifier. Okay, amplifier. Antennas will be introduced in second half. Okay, of this module. So in this is a transmitter. Typically, the last element for transmitter is a high power amplifier. Why we need a high power amplifier? Let also explain. Nowadays, for those mobile phone Wi-Fi, typically the distance is only maybe a few 100 meters. For Wi-Fi, less than 100 meters. But for those high power, for instance, radar, the distance could be up to 100 kilometer, 1,000 kilometers. Then the transmit power should be very high. Okay, transmit power very high. So very small. Also in the previous module, very small reflection will cause huge. Will convert a huge peak, right? So the matching is very so-called impedance matching is very important. So we will highlight impedance matching again in this model. Okay? So as I said here, maybe one very important work you could work is to design a good impedance matching, for instance, between the antennas and the amplifier. Okay? Or different portion, the impedance should be matched to minimize the reflection. Okay, minimize the reflection. So this is a typical block diagram for the transmitter. Okay. Then as for the receiver, typically the first stage typically is although here we have the low is a band pass filter. Typically is low noise amplifier. So in this module also we will explain why for receiver the first stage we should have a low noise amplifier. Okay. For low noise for receiver for this low noise amplifier. What specification we should expect for this low noise amplifier, okay, at the first stage, to improve the whole receiver sensitivity. But also we will explain what is the sensitivity for. Who can explain what is the sensitivity of the receiver?
Minimum power can receive.
Minimum power can be received by this receiver. Okay. For instance, the Wi-Fi signal, the sensitivity. What is the typical sensitivity? Who can give me the rough idea? Means sensitivity means the lowest power at that level, the Wi-Fi signal will not be stable, right? Okay? Will not be stable. Maybe around minus 90 dBm at that level, okay? Is the sensitivity, okay? So this is a component with high relevant related to the sensitivity, okay? So if you have a good this component, the system performance can be improved. Okay? So this very important. We will our mini project also is to design low noise amplifier. Okay? It is a board level, not chip level. Okay? It is a board level. For our FYP project, actually we have assigned students to work on this to design chip level noise amplifier, IC level. Okay? For this receiver, also you can observe we have this. This is the mixer. Mixer is a nonlinear. Mixer is a nonlinear device. Okay, to translate one frequency to another frequency. Okay, so means this with the carrier frequency by inputting this signal with the carrier frequency. This is the so-called local oscillator. Then translate this to a useful desired signal, right? Desired signal. Also, we have the amplifier. Okay, amplifier. Then demodulate. Then the information can be obtained. Audio, video signal, right? Okay. Also here we have this antenna, right? No matter transmitter or receiver, we have those common function blocks like amplifier. So in the first half, we spend quite a lot of effort on amplifier design. Okay, for many projects, right? Our lecture sessions, right? Yeah, of course. In our quiz and our final exam, we also have very important portion on the amplifier. Okay? On the amplifier. Okay? So all these components need to be connected with transmission line. Okay? The transmission line can be coaxial cable, microstrip, or waveguide. Okay? Later we will explain. Okay, now let's have 30 minutes break. Okay? 30 minutes break. Okay? We'll come back at 5. 7:25.